Hello everyone, welcome to the mechanics class. Let me share my screen. Please confirm if you are able to hear me properly and see my screen so we can continue. Can you hear me properly and see my screen? Okay, thank you. So first of all, the PDF files are uploaded in the drive location. You can go through the notes which till the class lecture number 5. Okay, and today it's lecture number 6, and till the last class I have uploaded all the PPTs. Okay, in the PDF format I have uploaded the notes. I didn't got chance to bring some homework problems for you on the statics part. Okay, I'll plan it on weekend. And so in today's session what we'll do is we'll solve some questions which I have given you for homework in the previous class, as some of you were not able to solve it. And then uh, we'll continue the topic of kinematics. Okay, in the last session we have started the kinematics, right? And we understood, or we started learning the uh, part of let's say variable acceleration problems. Okay, so we'll continue it. What was the first homework question? The velocity of the particle moving along x-axis is v is equal to ax cube minus 4x square plus 6x. Okay, where v is in meters per second and x is in meter, and k is a constant. Okay, if k is equal to 1, then value of acceleration when x is equal to 2 meter would be. Okay, and the answer here was 8 meter per second square. uh, Anyone was able to solve this? Are you able to solve this, or how many of you have solved it? Okay. Then let's solve it here. Velocity is given and they are asking us for the acceleration. What is acceleration? Acceleration is change in velocity with respect to time. Okay, so it is 3x cube, sorry, 3x square dv by dx by dt basically, right? Plus 8x dx by dt plus 6 dx by dt. Okay, I'm by default considering here k is equal to 1 because it's a given. So if you take dx by dt common here, what you will get? 3x square plus 8x, sorry, minus 8x plus 6 into dx by dt. And what is dx by dt? That is velocity, and it's already given, right? This is nothing but the velocity, which is already given. So now if you put x is equal to 2, how the stuff will look like is 3 multiplied by 4 minus 8 multiplied by 2 plus 6, and dx by dt is um, let's say 8 minus 4 into 4 is 16 plus 12. 8 meter per second square. Okay, this is the acceleration. Okay, clear, everyone? Any doubt in this question? Okay, if no doubt, then I'll move towards the next homework question, which we have solved, which I have given for uh, you to try. The motion of a particle in a rectilinear motion is defined by A is equal to 6 root V, and when t is equal to 2 seconds, velocity is equal to 36 meters per second. Okay, and displacement is equal to 30 meter. The value of s, then s at t is equal to 3 seconds is. Okay, and answer here was 87 meters. How many of you are able to solve this question? Have you tried it? Yes, good. So let's try to solve it. A is equal to 6 root V. A is dV by dt, and that is equal to 6 root V. If we take integration on both the sides, dV by root V is equal to 6 dt, you can say, and then you can rather take the integration. Uh, Integration of 1 upon root V is V raised to the power plus 1 by 2 divided by 1 by 2, and that is equal to 60 plus C. Okay. Given that at t is equal to 2, V is equal to 36. So under root of 36 is 6. So 2 times 6 is equal to 6 into t is what? 3 seconds plus c. This implies t is 2, sorry. So this implies c is equal to 0. Okay. So this is the first part. So what is the total solution here? The total solution is 2 root v is equal to 60. What they are asking is displacement. So let's integrate it once again. So root v is equal to 3t. V is equal to 90 square, we can say. And what is v? Dx by dt is equal to 90 square. So x is equal to 90 cube by 3 plus c2. Okay. So let's call it as c1, and then now we have c2. So x is equal to 3t cube plus c1. Sorry, c2. And another, let's say at t is equal to 2, x is equal to 30. So 30 is equal to 3 into 8 plus c2. This implies c2 is equal to 6. Okay, so we got c1, we got c2. Now uh, then x at t is equal to 3 is. Okay, let's calculate it. At t is equal to 3, x is equal to 3t cube plus c2 is 6, we have just calculated. So x is equal to 3 into t cube is 3 cube plus 6, so 27 plus 6, and that is equal to 87. Okay, is it clear to you all? Okay, so let's if it is clear, then we'll try to solve some questions on the constant acceleration. Okay, as I mentioned before, for constant acceleration problem you will be using equations of motion. What are all the equations of motion? The first equation of motion is v is equal to u plus at. Okay, second equation of let's say motion is s is equal to ut plus half of at square, and the last equation of motion is v square is equal to u square plus 2as. Okay, these three are the equations. So let's try to first derive it and then we'll solve the questions on it. You know, acceleration is equal to dv by dt. So dv can be written as a times dt. And if we integrate the velocity from, let's say, initial velocity is at time t is equal to 0, initial velocity is u. At time t is equal to t, final velocity is v basically. Okay. So v minus u is equal to a times t, we can say. And what this says it, v is equal to u plus at. Okay. So this is the first equation of equilibrium considering a as a constant. Coming towards second equation of motion, we know v is equal to ds by dt. So what we can write it as a ds is equal to v dt. But we already know v is equal to u plus at. Okay. So we can write it as ds is equal to u plus at times dt. And now let's say you can multiply this dt inside u dt plus at into dt. And now if you integrate it, what will happen is integration of when time, let's say uh, t is equal to 0 to t, that time displacement is from 0 to s. So we can say s is equal to ut plus half of at square. Ut plus half of at square. And then we have third equation of motion, that is v square is equal to u square plus 2as. We have a, that is dv by dt, you know. And what is v? V is equal to ds by dt. So we can say ds by dt uh, or let's say uh, what we can say here is, yeah, I can say here a times. So let's multiply both the sides with the ds by dt. So a times ds by dt is equal to dv by dt into ds by dt, or let's say v times dv by dt. That is also correct. So you can cancel out ds and just integrate with respect to the uh, the ds. Okay, so we are integration of ads is as when s is, let's say, from 0 to s. At that time the velocity is from u to v, so it is v square by 2 ranging from u to v. So as is equal to v square minus u square divided by 2. So v square is equal to u square plus 2as. Okay, so that's how we can derive all the equations of motion. Okay, I hope it is clear. It's just for your understanding, you know, you just have to remember it. No need to remember the derivations, but you should aware that these three equations are derived considering a as a constant. Okay, because you can clearly see here I have treated a as a constant, so you keep that thing in mind. So whenever you deal with any kind of constant acceleration problem, you can apply these equations. So let's try to solve some questions on it. Just a minute. Let's take first question. Stone is dropped from a height after having, okay, first of all, like a stone is dropped from a height. After 5 seconds from the rest or from rest, the stone breaks glass. Okay, uh, and let's say in breaking the glass, stone loses 20% of its velocity. Full stop. The distance traveled by stone in next second is. So I hope you understood the question. I'll repeat. A stone is dropped from a certain height. Okay. So after 5 seconds, there is a glass. Okay. So in 5 seconds, this is a glass is there. In 5 seconds, it breaks the glass, and during this breaking the glass, it loses the 20% of the velocity. So what is the distance traveled by the stone in the next 1 second? Next second. So distance traveled 1 second after breaking the glass. Okay, that is the question. Is it clear to you all? Any doubt? Okay, if no doubt, then solve this question. Post your answer in the group whenever you are done. Anyone? Anyone solve this question? Post your answer. 33.3. No, Pranjal. Okay. Uh, 53.4 also is not correct. Hmm. Okay, let me help you out in this. Let's solve it. So, so what they have mentioned is after breaking the glass, stone loses 20% of its velocity. So what will be its velocity just before breaking the glass? Okay, so v is equal to u plus 80. Okay, this you can use the equation. Weber answer is wrong. So v you have to calculate. U is 0 because you can clearly see after 5 seconds from the rest they are saying means from let's say at initially velocity is 0, so u is equal to 0 plus a is acceleration due to gravity, that is 9.81 into time is 5. Okay. So how much it is? 49 point something, maybe 0.5 meters per second. Yeah. Okay. This is the velocity. And what will be the velocity just after breaking the glass? Velocity, let's say uh, v1, let's call it as, or u1, let's call it as u1. That will be equal to 49.05 multiplied by zero point 0.8. Okay, 0.8 should be 39.24 something. Yeah, something like this. And this will be the initial velocity, you can say. Velocity for the next motion of 1 second, right? So what we have to calculate is displacement or distance traveled. This is equal to ut plus half of at square. U is 39.24. T is 1 second plus half of 9.81 into T is 1 square. Uh, how much? Close to 45 you should get. 45 is the correct answer. Check it. Yes, close to 44, 45 something you'll get. Yeah. Okay. So is it clear to you all? So looks like more specifically 44.1 maybe. Yeah. Okay. What is 0.8? Okay, we got one question from Nima here. What is 0.8? See, what is the sentence here, Nima? If you can understand the in breaking the glass, stone loses 20% of its velocity. Okay, what was the velocity of the stone? Close to 50 meters per second, right? So, if what is 20% of 50? It is close to 10, right? So, 10 meters per second velocity will become less after breaking the stone, right? So that's why 50 minus 10 is close to is 40. So if we accurately calculate, it's 39.24 is what we'll get after multiplying with zero point 0.8. You understood why we are multiplying uh, with a 0.8, Nima and Deepashri? Because we are taking into the account that after breaking the glass, stone loses the 20% of its velocity. So Velocity after breaking the glass will be 0.8 times the velocity just before the impact with the glass. Is it clear, Dipashri? So, okay, good. Let me give you another question. From top of tower of height h is equal to 36 meter. The ball is dropped at the okay and dropped from at the same instant another ball is projected vertically upward from the ground. Okay, with u is equal to 18 meters per second. The distance down measured with respect to top of the tower at which both the balls pass each other. Okay. So I hope you understood the question. Let me explain you once again. So we have a tower of height 36 meter, and from this height we are dropping a ball down. Okay. At the same instant from ground we are tossing a ball upwards. Okay. At certain point we don't know where they'll cross each other. Okay. And let's say at a distance x, maybe x1 for example, and let's say this distance is x2. At x1 distance from top and x2 distance from bottom, basically these balls are let's say crossing each other. So that what they're asking is the distance measured from the top of the tower. So they're asking you to calculate x1. Okay, this is the question. Please try to solve it and tell me the answer. Uh, yes, 19.62 is the correct answer. Yes, some of you answered it already. So let's try to solve it. So if you can clearly see here, what we can understand is x1 plus x2 has to be equal to 36, right? So considering this, um, what how will calculate x1? 36 1 plus x2. How will you calculate x1? Ut plus half of 80 square. So initially velocity is 0. So 0t. Okay. So basically it's 0 plus half of gt square. And what about the x2? Initial velocity is 18 meters per second. So 18t minus half of gt square. So basically, if you add them, half of gt square plus 18 minus half of gt square, you'll basically cancel it out. 18t is equal to 36. This implies t is equal to 2 seconds. So means after 2 seconds, what will happen is they will meet or they'll cross each other. So x1 will be equal to 1 half into 9.81 into 2 square. So 9.81 into 2. So that is 19.62. Okay. Yeah, that's the final answer. Is it clear to you all? Any doubt in this? Okay. If no doubt, then maybe I will include little bit more complexity into it to the motion. Okay, let's understand some curvilinear motion part here. So write down heading curvilinear motion. Okay. Okay, so it's our projectile motion, you can say. So suppose you are tossing or throwing a stone at certain angle theta with respect to the horizontal. And so this is v naught x, and that is equal to v naught cos of theta. Let's say this is v naught y, v naught sine of theta, and v naught is the initial velocity. Okay, so we are throwing a body or stone at an angle theta with initial velocity v naught. The components of v naught is v naught x, which is horizontal component. We can call it as a v naught cos of theta. Vertical component v naught y, you can call it as a v naught sine of theta. Okay. After some time, the stone may, let's say, come here at this point. Again, a tangent to this curve will be the direction of velocity. So v1 will be the velocity. Horizontal component will be v1x. Vertical component will be v1y again. Okay. And at certain point, the with the velocity is, let's say, Vx only. Okay, there will not be a Vy. Vy will be zero in that case, because the tangent to this curve is horizontal. It means vertical component of the velocity is zero at that point. Only the horizontal component is there. Okay, and then again, as you go on, what will happen is um, horizontal component is still there, and vertical component will come downwards. Okay, is it clear how the velocity will look like throughout the journey? Okay, so now as a projectile motion, okay, we got one question from Shivam here. Why Vy is zero? If this curve in a blue color is curve traced by that stone, then how you will calculate velocity, Shivam? The velocity will be the tangent to the curve, right? So if tangent to the curve itself is horizontal, then how can you take a vertical component of the horizontal? Okay, so if you have this, let's say one velocity making an angle theta, then you can have, let's say, Vx and Vy. But if V itself is horizontal, then that will be equal to Vx, right? Vy will be zero in that case. Are you following? Okay, good. So from the curvilinear motion point of view, what you should know is at what angle you can say you'll get the maximum range. So basically, some concept you should know. So let's say, okay, this is range. This is H max. Okay. So what you should know is theta for max range. You should know. You should also know how to calculate the range of the projectile motion, how to calculate the H max, how to calculate, let's say, H max mean the maximum height the projectile can reach. Okay, and time for range. It means how much time the particle will take to travel the entire range. T of H max means how much time the particle will take to reach the maximum height. So these all are very important points you should know when it comes to the uh, curvilinear motion or projectile motion. Okay, so you should know how to calculate it. You should also know, let's say, if a particle is thrown at certain angle with initial velocity, what will be the velocity after certain time? Okay, so let's call it as v1. How to calculate v1? V1 is velocity after certain time. So all these things you should know how to calculate, and then only let's say this concept will be clear to you. So let's try to understand some of these things to through some derivation. So the assumption here is like, the projectile motion is under the action of gravity. That is why the projectile is coming down after reaching the maximum height. So we have g as acceleration, which is in the y direction, and there is no acceleration in the x direction. That is the assumption. Okay, g in y direction, no acceleration in x direction. Okay, so with this, can you tell me if initial velocity is v naught and the two components is v naught x and v naught y. Okay. Can you tell me how the v1y will look like? v1y will be equal to, considering v is equal to u plus at. Okay. Can I write v1y is equal to v naught y minus gt? Okay. Yes, v naught y minus. And what is v1x? What is v1x? Yes, that is equal to v naught x only, because we don't have any uh, acceleration effect along x direction. So using this, can I calculate v1? Okay. So like this, you should be able to get the value of the velocity of the projectile after certain time t. Okay. So I hope at least you understood this part, how to calculate v1. That is velocity after certain time. Any doubt till this? Is it clear? Feel free to ask if you have any doubt. Otherwise, I will move towards the next part. Okay. Assuming that you understood. The next is, let's say, when y component of velocity becomes 0, the particle reaches its maximum height. Okay. So what I'm saying is, when y component of the velocity becomes 0, the particle reaches its maximum height. What was the y component of the velocity? v1y was v naught sine of theta minus gt. So after certain time, v1, so at certain time, v1y will be 0, right, when it reaches the maximum height. So can I say v naught sine of theta minus g times t when it reaches h max? Okay, is equal to 0. So from this time at which it reaches the maximum height is equal to v naught sine of theta divided by gt. Okay, so this is the time for reaching the maximum height. Okay, so I hope this part is clear to you now. Okay, now you got the time at which the particle will reach the maximum height, but what is the maximum height that we should calculate? H max, you know, s is equal to ut plus half of at square. So h max is u is v naught y, because v know y component is the only which is causing the vertical motion. Okay, so that's why I'm considering v naught y into t of h max plus half of minus half, because we are working against gravity, g into t max. Okay, square. Yes, Nave, thanks for correcting it. V naught sin theta by g it will come. Yeah, because t we have taken already out. So let's put this value here. H max is equal to v naught y, that is v naught sine of theta And t for h max is again v naught sine theta by g minus half into g into v naught sine theta by g whole square. Okay, so this 1g and 1g here will get cancelled. Okay, so v naught sine theta by g, when v naught v or v naught square sine square theta by g, you can take common, you'll get 1 by 2. So directly we can write v naught v square sine square theta by 2g we can write is equal to h max. I hope you understood how to find the maximum height the projectile can reach. If I just tell you what is the maximum height projectile will reach, and what is the time at which the projectile will reach the maximum height, if I throw it at let's say initial velocity 10 meters per second, making an angle 30 degree with the horizontal. So I'm giving you v naught, I'm giving you theta, and that's all you need in order to calculate h max and th max. Okay. Yeah. I hope it is clear till this. Any doubt till this? Okay, if no doubt, then I'll move towards how we are writing the g in denominator. It's already there, right? See, v naught square sine theta by g is already here, and here g, 1g is getting cancelled. We have bracket a square, right? So that 1g will get cancelled. Another g is still there. So half of v naught square sine square theta by g is still there. So that is what, that's how I have written. Uh, okay, next is when the particle reaches, when the particle reaches range, range point. At range point, the height traveled will be zero. Height traveled or vertical distance will be zero. Vertical distance is zero. You know S is equal to ut plus half of at square. Using this, if you equate S is equal to zero, considering the vertical velocity v naught y and the time at which it ranges, at which it will happen is t range plus half of, sorry, minus half of g t range square. So basically 1 t range will get cancelled here. So t range will be equal to 2 v naught y divided by 2 v naught. What is v naught y? V naught sine of theta, right? So t range, I would say it has 2 v naught sine of theta divided by g. Okay, that's how we can derive it. And how to calculate range? Range. You know, well, this velocity is equal to distance divided by time. So distance is equal to velocity into time. Okay, velocity is displacement divided by time, and displacement is velocity into time. So using the same concept, range can be written as v naught x into t range. What is v naught x? V naught cos of theta into what is t range? 2 v naught sine of theta by g. So 2 sine of theta cos theta is sine of 2 theta. So it's V naught square sine of 2 theta by G is equal to range. Okay, is it clear to you all? Any doubt till this? Okay, if no doubt, then let's solve some questions on it. Okay, let's take a question. Particle moves along the path y is equal to x minus 4x plus 100. Okay, with no, not this. Let's take another one. I'll bring this later. Okay, a particle has the initial velocity. Let's write from fresh. Particle has initial velocity mm, of 100 meters per second up to the and let's say is thrown, making an angle 30 degree with horizontal. The component of acceleration constant ex is equal to minus 4 meter per second square, and ay here is minus 20 meter per second square. Okay, try to understand here. Here they have given ex also. Computing the horizontal distance traveled until the particle reaches 60 meter below its original elevation. Computing the horizontal distance traveled until the particle reaches 60 meter below its original elevation is original elevation would be. Okay, um here I want you to try this problem for homework. Okay, I'll just explain you what they are asking. Answer is 448 meter. Let's try to understand this. Okay, this is a good example for homework, just to try it out, spend some time on it. Anyway, we will solve it on weekend, but I want you to try on it. If you are able to solve it, means this concept is clear to you. Okay, this is 60 meter delta y or sy. Okay, a particle is has initial velocity 100 meters per second, is thrown making an angle 30 degree with the horizontal. Okay, and the component of acceleration is um, in this direction. We have minus 20 meter per second square, and horizontal direction the acceleration is minus 4 meter per second square. Okay, so this is the given data. Try to use this given data and solve this question. What they are asking is uh, the distance traveled by the particle. So this total distance they are talking about. Okay, Sx for Sy is equal to 60. What is Xx? Okay, I hope you will be able to solve this question. Okay, take this for homework. If you are not able to solve, don't worry. We will solve it on weekend. But I'm intentionally giving this to you so that you can spend some time. Whatever derivation we have done is for ax equal to 0. We have acceleration only in the y direction. Here I'm giving you ax also. So I want you to work on it, think on it, and solve. What will change? What will not change? Okay. Let me give you one more question, which we'll solve now. The proportion the maximum range of a uh, projectile be increased if initial velocity is increased by 10 seconds. Oh, sorry, 10% will be. Okay, solve this question. The answer is in percentage. I'll repeat the proportion, the maximum range, okay, or the percentage, the maximum range of a projectile be increased if the velocity is increased by 10%. Try to solve the question. Anyone? Very simple question. Okay, one more question.
10%
Yes,
or in
it's a 21%. Yes, Shivam, you are right. What is the value of range? Range is what? V naught a square sine of 2 theta by g, right? What I'm saying is the initial velocity is increased by 10%. Means initial velocity is 1.1 V naught a square sine of 2 theta by g. And if you solve it, what you will get is 1.21 V naught a square sine of 2 theta by g. And now if you compare, yeah, if you compare, you can clearly see it's 21% more uh, than the initial one. So it's a it will increase by 21%. Okay. Let me
But
give
can you
another.
explain again? I'm not getting this.
Okay. You understood this formula for range. Range is equal to V naught sine of 2 theta divided by G, right? This is clear. Then what is asking the question? They are asking uh, the proportion, the maximum range of the projectile will increase, or the percentage by which the maximum range of the projectile will increase if initial velocity is increased by 10%. Initial velocity is V naught. We have to increase it by 10% means what? 1.1 times V naught, right? So in this formula, I'm replacing V naught by 1.1 times V naught. So V naught square will become 1.1 V naught square sine of 2 theta divided by G. And now, what is 1.1 square? 1.1 square is 1.21. Okay. So 1.21 V naught square sine theta by G. So if you compare it, you can clearly see by 21% our answer got increased. Okay. So our range got increased. Is it clear now?
Yes, sir, it's clear now.
Yeah. Next question. A particle is projected with a velocity 100 meter per second. Theta is equal to 60 degree. Determine velocity from a height obtained and horizontal distance traveled after 2 seconds. Okay. Try to solve this question. A particle is projected with a velocity of 100 meters per second, making an angle 60 degree with the horizontal. Determine the velocity, height obtained, and the horizontal distance traveled after 2 seconds. Okay. Also calculate. Let's make it bigger problem. Also calculate H max and T range. Also calculate H max and T range. Okay, this last question. We'll close it early today. I'm not feeling well because of cough and cold. So try to solve this question, and after this, we'll end the session. Also calculate max and range. Okay, post your answers. I'll wait for 2 minutes. Yeah, post your answers. Yeah. Have you solved it? Yes. Okay. Some of the answers are here. Let's try to solve it. Okay. Just a minute. Okay. So let's solve it. Some of you have answered already. Let's see how correct it is. Okay. So starting with the velocity, v is equal to u plus at. So v naught x is the horizontal component of the velocity after 2 seconds. Initial velocity is 100, so horizontal component will be 100 cos of 60 minus 0, because acceleration is 0 around the horizontal direction. So this is our v naught x. And so what is, because v naught is 100, okay, v naught y is what? 100 sine of 60. Okay. What is v1x? v1x itself is equal to v naught x, and that is equal to 100 cos of 60. And what is v1y? v1y is equal to v naught y minus gt. Okay, that is 100 sine 60 minus 9.81 into 2. How much? I think you'll get 66.98. So v1 is equal to under root of v1x whole square plus v1y whole square is equal to under root of this is, I think, 50 square plus 66.98 square. You will get close to 83.58 meters per second. Okay. Now next is uh, we got the first velocity. Okay, what they have asking us, the height, horizontal and vertical height. height obtained. So Sy will be equal to, S is equal to ut plus half of at square. Using this formula, Sy is equal to u is 100 sine of 60 into 2 minus half of 9.81 into 2 square. Okay, this will give us the distance in vertical direction, that is height obtained. It will give, that is 153.58 meters. Okay, uh, yes, Pranjul, you got it correct. Navya also. And then Sx is the horizontal distance, and same formula, ut plus half of at square. So here u is what? U is Vx into t, and acceleration is 0, so just Ux into t. Ux is how much? Ux is 50 into 2, so it is 100. Yes, now we are correct. 100 meters is the horizontal distance. Then we have H max, that is equal to V naught square sin square theta by 2g, 100 square into sin square 60 divided by 2 into 9.81, 382.26 meter is the H max. Range V naught square sin of 2 theta divided by g, 100 square into sin of 120 divided by 9.81, and that is 82.79 meter. Okay, is it clear? Anyone have any doubt in this? Because in this question, majority of the things we have solved. We have calculated H max, we have calculated the range, we have calculated the velocity, horizontal and vertical distances as well. Okay. So in the next class, we will solve a couple of more questions on it. Also, we'll solve the homework question. Okay, and then the next topic for you will be fixed axis rotation. Okay, or you can call it a circular motion as well. So in that, we'll study the concept of centripetal and tangential acceleration, or tangential and normal acceleration, and all. Um, yeah, and we'll solve some questions on it. Okay, and then later on we will start the uh, you can say some problems which are related to the instantaneous center, but I hope it will be covered into the theory of machines, so we'll not focus more on it. Instantaneous center method is part of your uh, Tom subject. Okay, but the other parts will take care here, like in the kinematics, like fixed axis rotation and all, and then in the at the end, if time permits, we'll start the kinetics. Okay, so that's all for this weekend class. Okay, um, so I expect like we'll start kinetics on this weekend, and um, cover the fixed axis rotation. Okay, if possible. Okay, Sanjeev, I'll come to the slide where I have given you the homework question. Yeah, this is the one. 448 is the answer. Okay, so that's all from my side today. If you have any doubt, feel free to ask. Otherwise, we'll end our session here. Okay, so thank you all for joining this class, and let's meet again on weekend. We have class on Saturday and Sunday. Okay, thank you all. Bye. Good night. Yeah, I'll upload the PDF file of this class as well.